All right, section 5.2, congruent polygons. So some vocab here. The first one is corresponding parts. So corresponding parts, corresponding means to kind of go together. We've dealt with that before in corresponding angles in chapter 3. So corresponding parts are corresponding angles and corresponding sides. Sides and angles that kind of match together. So if I have triangle ABC and I have triangle, let's maybe flip it upside down, DEF, and I tell you that triangle ABC is congruent to triangle EDF. What that means is that angle A and angle E correspond. A and E correspond. Notice they are both first in the congruent statement. Angle B and angle D correspond because they're equal, they go together. And then angle C and angle F also correspond because those are the ones that are equal. They're also the third in the list. Then also we know that AB, side AB corresponds to ED. DF and BC correspond, and AC and EF correspond. Those are the ones that go together. They match up both in the picture, in the congruencies, and in the congruency statement. The reflexive property of triangles. Basically, these three properties, I don't use them a lot, but they do exist. So the reflexive property is that triangle ABC is congruent to itself. The reflexive property is when something is congruent to itself. The symmetric property says that if the first triangle is congruent to the second triangle, then the second triangle is congruent to the first triangle. To me, these make a lot of sense. Like, yes, if the first one and the second one are exactly the same, then the second one and the first one are exactly the same, because they're exactly the same. The transitive property, we used the transitive property back in chapter 3 also. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, then triangle ABC and triangle JKL are congruent. Essentially, if the first is exactly the same as the second, and the second is exactly the same as the third, then the first and the third are exactly the same. The last one, the third angle theorem. Let's see here. Maybe we have triangle ABC and DEF. If I tell you that angle A is exactly the same as angle E, A and E are congruent, and angle B and angle D are congruent, then angle C is congruent to angle F. And this is, not anything that's used a whole lot, and it's kind of straightforward in the fact that if A and B are exactly the same as D and E in measure, then that means they add up to the same number. And we know that triangles themselves have to add up to 180. So let's say these add up to 160. This would have to be 20, so that it adds up to 180. These would also have to add up to 160, which means F would also have to be 20, because both triangles have to add up to 180. So example 1. List all pairs of congruent corresponding parts. Then write another congruent statement for the polygon. So list all congruent corresponding parts. Some of them are obvious. It is a lot of writing, but it's not particularly, it doesn't seem very mathy to me because of how much writing it is, quite honestly. So let's look at the picture. Is there anything marked congruent? Angle R and angle U. Those are congruent. Angle R is congruent to angle U. Are there any others? Angle Q has two swishes, And angle T has two swishes, so angle Q is congruent to angle T. Angle P is congruent to angle S. 3 swishes, 3 swishes. Now the unfortunate part, we're only halfway done. Those are just the congruent angles. We also have congruent corresponding sides. So let's see here, side RQ. RQ goes from 1 swish to 2 swishes. So in this picture, go from 1 swish to 2. UT. So RQ is congruent to UT. Then QP, 2 swishes to 3 swishes, 2 to 3, TS. QP is congruent to TS, and then maybe 3 swishes to 1 swish, PR is congruent to SU. Great, those are the congruent corresponding parts. Now when it wants another congruent statement, the congruent statement is this sort of thing right here. They want us to make another one of those. So what we do, instead of saying PQR, we need to make a new name. So I'm going to go RQP. Why? Because I went from 1 swish to 2 swishes to 3 swishes. I went in numerical order of the little marks in the corner. That's all. It's not necessary to go that way. In the second one, I went from 1 swish to 2 to 3. UTS. Now I want to point out, as I'm looking at these pictures, the pictures themselves are actually fairly irrelevant once you have a congruent statement. Because I'm telling you the order they go in. It goes PQR and STU. These are the orders they match in. So, for example B, I'm not going to look at the picture at all. You can look at it if you want, but it's not necessary. Totally ignore it just for a moment. ABCD is congruent to EFGH. That means angle A, matches up with angle E. Angle A is congruent to angle E. B and F go together. Angle B is congruent to angle F. And I just go down the list. C and G and D and H. Those are the angles. We also need sides. Sides require 2 letters that are next to each other. So AB, side AB is congruent to EF. BC and FG. CD, GH. Now, I know technically I said the letters need to be next to each other, but remember, we're going in a circle. So A goes next to B, but A also is next to D. So AD is congruent to EH. Now, when I reorder these letters, keep it going in a circle. So for me, instead of A, B, C, D, I probably would go D, C, B, A is congruent. So I went from the right to the left. Same thing, H, G, F, E. That's the congruency statement. Example 2, find the values of x and y. So looking at this, triangle XYZ is congruent to triangle RST. And let's see what we have. Right here, the congruency statement tells you how these match up. X and R, because they both come first, they have the same measurements. So like here, I know angle S is 30. S is the middle one. So that means angle Y, see how they're both in the middle, Y is also 30. Angle Y. Well, angle Y is 2x minus 20. So 2x minus 20 has to be equal to 30, and that's something I can solve. So 2x equals 50. X is 25. Let's see here. XZ is the first and the last. Go with RT. So XZ is 15. So RT also must be 15. Now the other thing, look at 3y plus 9. We have some congruent marks here. So this is 3y plus 9, this is 15, but they have the same length, so 3y plus 9 must be equal to 15. Subtract 9 from both sides, 3y equals 6, divide both sides by 3, y must equal 2. Now in this particular problem you did need the picture to see what the numbers were and the values, but you're setting things equal, and I'm looking significantly at the congruency statement when I do that. So the next one, a quadrilateral ABCD is congruent to quadrilateral EFGH, and we're looking again for X and Y. So let's see here. Here's a 62 in angle C. C goes with G. That means angle G must be 62, which means 8y minus 3x must be equal to 62. And right now this isn't anything we can solve because we have both an x and a y. We're going to need to substitute something in order to solve this. So let's look at E. E is 108. E corresponds to A. They're both first. So angle E is 108, which means angle A must be 108. 60 plus 8x equals 108. And this is something now I can solve. Subtract 60. 8x equals 48. Divide both sides by 8. And x equals 6. Now I can plug it in. 8y minus 3 times 6 equals 62. 8y minus 18 equals 62. Add 18 to both sides. So 8y equals 80. Divide by 8. Y equals 10. 6 and 10. Example 3. Show that the polygons are congruent and explain your reasoning. So at this point in time, all we know in order to show that things are congruent, we need to list all of this. We need to show that all the angles are congruent, all the sides have a congruent corresponding part, and then we can write the similarity statement. But you have to list them out. The more sides your polygon has, the bigger your list is. So let's see here. Do you know anything that is congruent in picture 3A? Angle A and angle C are congruent. And we know that because they're marked in the picture. We also know that angle ADB is congruent to CDB, angle CDB. And the reason for that, remember, together these two make a linear pair. That means they add up to 180 degrees. This one's 90, so this one must be 90. So I'd probably say linear pair. Now, angle B, the top angle B and the bottom angle B, those aren't marked. But they are going to be congruent. and how we know that angle ABD is congruent to angle CBD is this third angle theorem. It says if two of the three angles have corresponding congruent parts, then the third angle is also congruent. So notice A and C are congruent, the two D angles are congruent, so the two B angles are congruent. It's the third angle theorem. Now we need the same sort of thing with the sides here. We know side AD is congruent to side CD because they both have two tick marks. We know side AB is congruent to side CB by the one tick mark. And then we also know that BD is congruent to BD. BD is congruent to BD. Now it seems at the beginning of geometry almost a silly thing to write down because yeah, of course BD is congruent to itself because this is the same thing twice. So what's going on here is that it's called the reflexive property. It's when something is congruent or equal to itself. And it is necessary in this case to acknowledge and point out the reflexive property. We're going to use it significantly more the next lesson that we have. So now we have shown that the polygons are congruent because we showed all three angles have congruent corresponding parts and all three sides have congruent corresponding parts. 3B, same sort of thing. So let's see here, angle L, one swoosh is congruent to angle H. Angle M, two swishes, is congruent to angle I. Angle N is congruent. Now, there are two 90-degree angles and two 90-degree angles. We need to make sure that we get the correct match. So there's N and there's K. Well, notice N is next to the, I believe that's 4 tick marks. So which one, G or J, is next to the 3 tick marks? J. So angle N is congruent to angle J, and angle K is congruent to angle G. Now we also need sides. Now the benefit for me of doing angles first is that it tells me which letters match up. L and H correspond. So if I say LM, this side here, look, L goes with H, M goes with I. LM corresponds to HI. MN corresponds to IJ. NK corresponds to JG. The last one I just got to be careful. KL, so I went from the bottom one to the top one. That's GH. And now these polygons are congruent because they have congruent corresponding parts. All right, example 4. Find the measure of angle 1 in each of these pictures. So the more geometry we do, the more things kind of pile upon one another. So everything we've learned up until this point is fair game. So when I look at this picture, quite honestly, the first thing I see is right here in the middle, the X. We have vertical angles. That's a 54 right there. Now, as it turns out, That's not even needed. But it's the first thing I see, so I'm going to put it down because it can't hurt. So let's see here. Angle 1, this is what we're looking for. It is congruent to the U. Angle U. So if we can find U, then we know X. If we can find the measure of angle U, we know the measure of angle X because they're equal. Up here, we have a triangle. Right there. We know this angle is 80 and this is 54. We also know that the angles of a triangle must add up to 180. So 80 plus 54 plus X, we'll put an X there, has to equal 180. So 134 plus X equals 180, and solve. Subtract 134 from both sides. X equals 46. So the measure of angle 1 equals 46 degrees. Now technically X was 46, but we know that this one down here is also 46 because they are congruent. Example 4b. I love this example. Every time I look at it, I momentarily just draw a blank. It looks horrible to me. There are a lot of things going on here. We have some 90-degree angles. Look, we even have vertical angles here. The left and the right are vertical. There are there are 3 little triangles. There are 2 like medium-sized triangles here. The medium-sized triangles share the side BC. There's a lot going on in this picture. But we're looking for this angle right here, the measure of angle 1. And if you can keep yourself from essentially panicking, this problem's pretty, in my opinion, remarkably simple. Look, angle 1 has a swish in it, has a congruent mark. Is there any other place in this picture that has one swoosh for a congruent mark? Angle A and angle D. All 3 of these angles are marked as congruent, which means the measure of angle 1 is 33 degrees. And why? Because it has one mark just like angle 1. And with this, you should have enough information to go ahead and do your homework for section 5.2.